All right, today we're diving into a really cool breakthrough in theoretical physics that seems to reveal a hidden pattern woven right into the universe itself. You can think of it like a story about a secret mathematical language that's been there this whole time, just waiting for us to finally learn how to read it. So let me ask you this. What if the universe is governed by laws that have this incredible, profound elegance, this symmetry? But what if one of the most beautiful and fundamental parts of that design has been completely hidden from us, just out of sight? Well, that's the big question at the heart of what we're talking about today. To even begin to understand this hidden pattern, we've got to venture into one of the most ambitious and frankly mind-bending ideas in all of modern physics. We're talking about the world of 10-dimensional supergravity. Now, I know supergravity sounds pretty intimidating, right? But you can really just think of it as a proposed blueprint for the universe. It's this massive attempt to create one single, elegant theory that can explain both the huge scale of the cosmos, governed by Einstein's gravity, and the bizarre world of tiny particles, which is all about quantum mechanics. And here's the wild part. It does this in a universe with 10 dimensions, not just the 4 we're used to. So this grand theory, it comes in two main flavors, known as Type 2A and Type 2B. Now, they have some slightly different properties, technical stuff about how particles behave, but physicists have known for a while that they're basically two sides of the same coin, deeply connected through some really cool math. And this right here is where our mystery really begins. Because inside these beautiful, elegant theories, something incredibly important was missing. A powerful symmetry that everyone, and I mean everyone, expected to be there. It just wasn't. It had vanished. But hold on, before we go any further, let's make sure we're on the same page. When a physicist gets all excited about symmetry, what are they actually talking about? The easiest way to think about it is to picture a snowflake. You can spin it by 60 degrees and it looks exactly the same, right? That's a symmetry. Well, in physics, symmetries are way more profound. They're not just about looking nice. They point to a deeper, unchanging law of nature. They are the ultimate sign that there's an underlying order and elegance to how the universe is designed. So here's the problem. A very specific, very powerful symmetry called SU8 was predicted to be a fundamental part of 10D supergravity. Having it there would make the whole theory feel, well, more complete, more elegant. But when physicists looked at the standard equations, nope, it just wasn't there. It was this big, glaring hole in what was supposed to be a beautiful picture of the universe. So, to solve this mystery, you couldn't just keep looking at the problem the same old way. You needed a totally new approach, a revolutionary mathematical tool that could actually reveal what was hiding in plain sight. And that tool is called the spinor moving frame. Now, don't get hung up on the name. Think of it less like a new theory and more like a new pair of glasses, or maybe even a Rosetta Stone for physics. It doesn't change the underlying reality, but it translates the ridiculously complex equations of supergravity into a new mathematical language, a language where its deeper structures suddenly become clear. And this is just a perfect example of the power of a new perspective. By just reframing the math, this new approach sliced right through all the complexity that was hiding the symmetry. It was literally the key that was about to unlock this whole mystery. So, armed with this powerful new lens, researchers Igor Bandos and Miriam Sulaya went looking for that missing symmetry again. And what they found, well, it was about to change our whole understanding of supergravity. Their process was so methodical, so elegant. Okay, first, they started with the standard model of a particle in 10 dimensions. Check. Then, they applied their brand new spinor moving frame perspective. And after one last mathematical step, boom. It was like shining a black light on invisible ink. The hidden SU8 symmetry just popped right into view. And there it is, the big aha moment, straight from their paper. It reveals the hidden SU8 symmetry. I mean, can you imagine? After all that searching, the missing piece of the puzzle was finally found. And get this, the discovery was even more amazing than they expected. The symmetry wasn't just in one version of the theory. It was perfectly preserved in both Type 2A and Type 2B. The two sides of the coin shared the exact same hidden beauty. All of a sudden, the blueprint for the universe looked way more elegant and unified than anyone had ever realized. So, okay, a hidden symmetry was found in a 10-dimensional theory. That sounds pretty abstract, I get it. But what does this actually mean for physics? Why should we care? Why does this discovery matter? All right, let's break down the key takeaways. First, this pretty much confirms that physicists were on the right track. The universe really does seem to have this deep mathematical elegance. Second, it gives them a powerful new way to calculate something called superamplitudes. Just think of those as the basic rules for how particles interact and smash into each other. It's always been incredibly hard to figure them out, but this new approach could make it a whole lot easier. Third, it proves the two versions of supergravity are even more connected than we thought. And finally, it just blows the door wide open for future breakthroughs by showing how important these hidden symmetries really are. And that brings us to a final and, honestly, pretty thrilling thought. The SU8 symmetry wasn't hiding in some far-off, undiscovered corner of the cosmos. No, it was right there, in the math we already had, just waiting for someone to look at it in a slightly different way. It really makes you wonder, right? What other huge secrets of the universe are hiding in plain sight, just one new perspective away from being revealed?